Hello. In this short video clip, we are going to cover an example of the rod cutting dynamic programming algorithm as presented in the CLRS text. So we are going to be using this table as our example of what the inputs are. So remember the way that the specifications for a rod cutting problem are given to us. We are given the n lengths. So those are the values, the first two columns here. We need to know what is the length and what is the price or the profit for each length. The next two columns are the values we're going to try to derive or figure out. So that's what the algorithm will do. And then we're going to be using this extended bottom-up cut rod example. So in this particular example, we know that the total rod length is equal to 10. That's why the rows are numbered from 1 to 10. So using this, we are going to go ahead and initialize our structures. So based on the algorithm, as it's given in the text, if you will notice, we have two for loops. We have a for loop on line 3 that runs j from 1 to n. So we know that we have for j, and j will run from 1 to n, so using that as a reference. And then on line 5 is the inner for loop, where I runs from 1 to j. So I know that inside, we have a value for I that runs from 1 to j, okay? So those are our givens. So since the outer for loop is based on j, we are going to keep track of the various values for j. So let's start developing our table to keep track of what's going on. So we need to keep track of a j value, so that's the iteration. We want to keep track, because this is our table that we're trying to generate, we want to keep track of our price sub j. So we will have a p sub j value, right? So that's the other thing. And then finally, we're going to be calculating what the revenues are, or the optimum revenue at length j. So these are the three values that we're going to be calculating. So in the algorithm as given in the text, you will notice that the R table is indexed from 0 to n, and the S table is indexed from 1 to n. So we're going to go ahead and indicate that on our table. So that means our j values, we might as well start them off at 0. Okay, so we run up to 10 because that is the length of our of the rod. The R0 value on line 2 is set to 0. So we're going to go ahead and initialize the R0 value to 0. The P table, or the P vector, will only have 10 entries from P1 to P10. So that stays as is. The S value here from 1 to n, that will be indicated by the circles, because if you'll notice the way that the algorithm works, the S values are determined once we know the maximum for the jth iteration. So j is the iteration number, and I is the value of I for which we found a larger value based on line 6. We found a larger value to replace the current max. So Sj becomes I. It's just when we find the largest I, that the largest index I that beats the current maximum that we have. So let's go over this algorithm to see how it works. So clearly the P values are already given to us because that's part of the input. That's the first two columns of the table. So we're also going to go ahead and copy those over. So P1 is 1, P2 is 5, P3 is 8, P4 is 9, P5 is 10, P6 and 7 are both 17, P8 is 20, P9 is 24, and P10 is 30. So far, so good. All we've done is we've copied what was given. Now we're going to go over the algorithm. So the main part of the algorithm that we're going to be doing here is we're going to be calculating the maximum for each jth iteration. So the crucial part of the calculation is this if statement. So the current maximum Q is initialized to negative infinity because any other value will beat that negative infinity since we're trying to find the maximum. So the idea is every time we find a pair, a pi and an r of j minus I, so that's line 6, anytime we find a pair of p and r values whose sum beats the current maximum, we change our mind on line 7 to determine what is the new maximum. And then we keep track of that new maximum because that was determined by the I, because this if statement is inside the for loop for the index I. So we store that I value for the current iteration in the outer loop j. So that's what happens in line 8. So the idea here is once you understand where the pairs of p and r values are coming from our table, the algorithm actually becomes very easy to understand. So let's go through this. So when j is equal to 1, right? So I'm going to, I guess we'll keep track of that somewhere here. Let's see, let's put that here. So j and I. So when j is 1, right, I will run from 1 to 1. Right, those are the only values that we have. So when j is 1 and I is 1, the pair that we're going to be adding is p of 1, right? And then r of j minus I will be r of 0. So if we look at our table, all we're doing is we're adding up this value and this value. So if we do that, we are merely going to be adding up the value 1 plus 0, and this is just equal to 1. And that's the only value we're calculating. And since there's only one value, it will end up being the max. I'm going to put a circle around it to indicate that that's the max. Okay, so that's the first iteration. Let's move on to the next iteration. J starts at 2. Okay, now j is 2. I will start from 1 up to j. So we start off with I is 1. And then eventually we'll be calculating the value for I is 2. So notice the number of iterations for I is the same as the value of j. Just as that's just how the loop is designed. So for each row, we're going to have one calculation, one sum, and then two sums, and then three sums, and so on. In this particular example, up to 10 sums. So that's what we're going for. So let's take a look at what happens. So when j is 2 and I is 1, so I determines the price value. So if you'll notice, we always start with price 1 because the for loop for I always starts with 1. So that's our hint. Our p values start at row 1 and go down. Our j values always start at index j minus I. So in this case, it's 2 minus 1 is 1. Another way to look at that is since we're trying to fill out the entries in row 2, right? So the I values for the price start from row 1 down to row 2, There's only two of them because we only need two sums. The J values for the optimal revenue start from the previous row and go all the way up to 0. So we have this opposite direction going on. So the first pair that we're going to be adding up, we start with the first row and we add it to this value. So that will give us 1 plus 1. That's the first value. So that will be our current maximum since it's the first value we're calculating. And then the price goes to the next one, right? And then the optimum revenue goes to the next previous row. So it's 2 rows above us. So we're adding the 5 and the 0. So in this case, we have 5 plus 0, and that's a new maximum. So when we're done with this iteration, we should be picking this value as the overall optimum revenue for the iteration j equals 2. Right, so I quickly jumped over what happens when I equals 1 and then what happens when I equals 2. We'll do the same thing looking at the situation when j is 3. Right? And I probably won't be referring to those I and j values anymore because hopefully you can see where these values are going to come from. When j is 3, that means I will run from 1 to 3. So that's what we're going to simulate. So without referring to that anymore, because we've got all the information we need in front of us. So for row 3, the first calculation we're going to do is that the price always starts at the first price. So that's row 1. And since we're in row 3, the optimum revenue that we're going to add to the price sub 1 is going to be the optimum revenue on the previous row. So that's the 5 over here. That means the first sum we're going to calculate is 1 plus 5, which is equal to 6. Next, because we have 3 sums that we're going to calculate. The next sum we're going to calculate is that of the next price down the row. So now we're looking at price 5. And the optimal revenue is the one for the next row up. So we're calculating the sum of the 5 and the 1. So we have 5 plus 1 is 6. And then we continue with the third calculation that we need. So again, the price that we're looking at goes to the next row down. So we're looking at this 8. And that will be added to the next optimum revenue up. That means we're looking at this 0, right? So we're just doing this opposite direction for the 2. So in this case, we're adding 8 and 0. And this is 8. We're interested in the maximum. So when we are done, we need to be able to select the fact that the maximum of the 3 sums we calculated is equal to this 8, right? Okay, so that was the third iteration. Now we're going on, and I'm not going to keep track of the I and the j values anymore because hopefully what's going on is becoming clear, right? So we're on row 4. Prices start at row 1, so we're going to add up the 1 and the 8, right? So that is just 1 plus 8 is equal to 9. For the second calculation, we're adding up 5 and 5, right? So that's just 5 plus 5, which is 10. For the third sum, we're adding up 8 and 1. So that is just 8 plus 1 is equal to 9. And then finally, the last pair we're going to get is the price of 9 and the optimum revenue of 0. So that is just 9 plus 0 is equal to 9. Again, if the same value appears multiple times in the row, we only consider the very first time we see it because we replace our answer when we beat the answer. So only when it's greater than. If they're equal at each succeeding value, we're staying with the first occurrence. So in this case, the maximum would be 10, right? So moving on to row 5. Again, row 5, we're adding the price 1 and 10. So we add up 1 plus 10. It's just 11. Next, we add up 5 and 8. So 5 plus 8 is 13. Next, we do 8 plus 5. 8 plus 5 is 13. We do 9 and 1. 9 plus 1 is 10. And then our fifth and final calculation, we calculate 10 and 0, the sum. So 10 plus 0 is 10. And again, since we're trying to find the maximum, we would end up with this 13. It's the first time we see 13. Okay? Going on to the sixth iteration. In the sixth iteration, the first sum is 1 and 13, right? So 1 plus 13 is 14. So this is for row 6. Next, we do 5 and 10, right? So 5 plus 10 is 15. Then we do the third one is 8 and 8. So 8 plus 8 is 16. Fourth one, we do 9 and 5. That means 9 plus 5 is 14. Next, we do 10. So this is the fifth calculation. 10 and 1, right? 10 plus 1 is 11. Now we have a sixth calculation. So that's the 17 and the 0. So we have 17 plus 0 is equal to 17. And again, we calculate the maximum going left to right. That tells us that the maximum is this 17 way out here. Moving on to row 7. Row 7, again, price starts at 1. So we're adding the 1 and the 17. So 1 plus 17 is 18. That's the first calculation. Second sum, 5 and 13. So 5 plus 13. Okay. Third one, so the third calculation. So that's why I know it's the third one down the row. We are calculating 8 plus 10. Fourth calculation, 9 plus 8, right? So that gives us 9 plus 8 is 17. Fifth calculation is 10 plus 5, right? Sixth calculation is 1, 2, 3, 4, 5, 6. That's this. So that's the 6 and the 1. No, not the 6. The 17 and the 1. Thank you. And then finally, the last calculation is the 17 and the 0. So looking at our list of numbers, it looks like the largest value we have is the 18, the first occurrence of 18. Moving on, we are now at row 8. So we start with the 1 and the 18. So we have 1 plus 18 is 19. Second calculation is the 5 and the 17. Right, we're looking at the maximum of the previous row. So we have 5, correct that. 5 plus 17 is equal to 22. Third calculation is 8 and 13. So 8 plus 13, 21. Fourth calculation is 9 and 10. Right? 9 plus 10 is 19. Fifth calculation is 10 and 8. If I'm counting up correctly, right? So it's 10 plus 8. 4, 5, sixth calculation. 1, 2, 3, 4, 5, 6. That's this one. So we are adding the 17 and the 5. So we have 17 plus 5 equals 22. Right, so the next thing we're going to do is this 17, and that's the 7th. That's going to be added to the 1. So 17 plus 1. And then finally, the last sum for row 8 is going to be the 20 and the 0. So we're going to have 20 plus 0 is 20. And if we look down the line from left to right, it looks like the largest value we have is 22. 2 more rows. We're almost done with these rows. Now, fairly long example. So for the first sum for row 9, we're adding up the 1 and the 22, right? Because those are, 22 is the maximum from the previous row. So we're doing 1 plus 22. Second calculation, we're going to do 5 and 18. It's 23. Third calculation is the 8 and the 17. Right, so that should be the third one. So 8 plus 17 is 25. Fourth calculation is 9 and 13. So 9 plus 13 is equal to 22. Fifth calculation is 10 and 10, right? Sixth calculation is 17 and let's see, 1, 2, 3, 6, that's right. 17 and the 8. That's the first of the 17. So we're now in the second 17, which is our 7th calculation. So that means we're going to add up 17 and 5. Our next calculation is the 20 and the 1. So we're going to have 20 plus 1 is 21. Then we have one more calculation compared to the previous row, and that's adding the 24 and the 0. No cuts, right? That's what that corresponds to, if this is maximum. Again, we scan from left to right to find out what the maximum is, and it looks like it's going to be the 25, okay? One more row, and then we are done. So again, last row, 10 sums, starting with 1 and 25 are the two values we're going to add up together for the first sum. Okay, so 1 and 25. So we have 1 plus 25 is 26. Next, we have 5 and 22, right? So that's for the second sum that we're calculating. So we have 5 plus 22, right? Third, we have 8 and 18. So third is 8 plus 18, 26. Fourth, we're doing 9, and 17 is the fourth one, right? So 9 and 17. 9 plus 17, 26. Fifth calculation, fifth sum. We have 10 and 13. So 10 plus 13. Oh, not 26, 23. Sixth calculation, 17 and 1, 2, 3, 4, 5, 6, 10. Right, 17 and 10. Seventh calculation is the second 17. And 1, 2, 3, 4, 5, 6, 7 added to the 8. So 17 plus 8 is 25. Next, eighth calculation is 20 and the 5. So we're adding those two. So we have 20 plus 5. Next, we have 24 and 1. Right, that's the next pair. 24 plus 1 is 25. Finally, our last calculation for sums, for pairing sums, is 30 and the 0. That's no cuts. 30 plus 0, 30. So again, scanning these values from left to right, starting with the very first sum to the last sum, it appears that the maximum is the 30. So the main reason why we're keeping track of all the sums is the position of the maximum. So remember, in the algorithm, every time we're calculating sums, when we're done, the S sub j values will be containing the index I where we calculated the maximums, and we've circled those on our table. So let's see how we can generate the S table based on our circled values so far. And I should have had enough room for the S values, but I didn't have it here, so I'm going to squeeze them in here. What are the SJ values, right? So our S values start at index 1. We don't have them at index 0. So if you'll notice in index 1, there was only one value to calculate the maximum of. So the maximum happened at position 1. Right? It's not visible. Let's make that a little bigger. For row 2, the second one is the maximum. That's the one with the circle. So S of 2 is 2, right? S3 is 3. S4 is 2. S5 is 2. S6 is the last one, so it's 6. S7 is 1, it's the first one. S8 is 2. S9 is 3. And S10 is the last one, so it must be 10. So those happen to be our S values. So let me rewrite those numbers maybe on this table so they're more visible. So we have 1, 2, 3, 2, 2, 6. 1, 2, 3, 2, 2, 6. And then 1, 2, 3, 10. 1, 2, 3, 10. So that's what we have so far. So looking at what we have here, the table pretty much tells us that for a rod of length 10, the maximum revenue, the optimal or an optimal revenue we can generate from a rod of length 10 is 30. That makes sense. That's no cuts. So we can use this print cut rod solution algorithm to determine what the cuts are. So basically all we're doing is we're looking at the appropriate S value for the rod length we're looking at, and then we keep updating n by changing it to n minus Sn each time in this loop. So if we take a look at what we have for the length 10, right? So S sub 10 is 10. So now I'm replacing the 10 with 10 minus 10, which is now 0. So that means I only have a rod of length 10, meaning no cuts. So that's why the optimal decomposition says that for rods of length 10, I do not cut it. And again, based on the price column, the second column that's given to us, that is the right value. If we keep the rod of length 10 as is, the price or the profit we get is 10. Whereas, what if I looked at a rod of length 7? So again, based on the table, it is clear that the optimum revenue for a rod of length 7 is $18, let's say. And let's see how we calculated that optimal revenue of 18. So again, we look at the S column. So that's the blue text right here that we have. These are the S values that we have. So the S of 7 is 1. So I know I need a cut of length 1. That's the first cut. So that's how we generate this. We replace the 7, because we calculated S of 7. We replace the 7 with 7 minus 1. So now it becomes 6. So now we look at the S of 6 value. Notice that the S of 6 value is 6. So that's the next cut. 6 minus 6 is 0, so we stop. So the optimal or unoptimal decomposition of a rod of length 7 is 1 cut that results in a rod of length 1 followed by a rod of length 6. The cost of a rod of length 1 is 1. The cost of a rod of length 6 is 17. And that correctly gives us the sum of 18. So all the information we need for rods up to length n, in this case is 10, can be answered on this table based on the algorithm that we just used. I hope that this was helpful. Stay healthy and stay safe. I'll see you next time. Thank you. Bye.